Ladybugs, the tiny titans of nature. How can something so small capture so much human affection? With their glossy domed shells, bright colors, and charming little spots, ladybugs have fluttered their way into our hearts and folklore for centuries. Even their collective name sounds like poetry, a loveliness of ladybugs. From nursery rhymes to children's books, these insects are cultural icons. In medieval Europe, farmers prayed to the Virgin Mary for help when their crops were infested with pests. Soon after, red and black beetles appeared, devouring the invaders. And so they were named Our Lady's beetles, or ladybugs. In many cultures, they still symbolize luck, love, and protection. In some countries, spotting one on your hand means good fortune is on its way. In others, if it lands on you, it's said to bring a wish come true. But behind that innocent, storybook image lies a ruthless hunter. Ladybugs are efficient, ferocious predators, miniature lions of the plant world. One adult can devour more than 5,000 aphids in its lifetime, and their larvae are even hungrier. When aphids, those soft-bodied, sap-sucking pests, become scarce, ladybugs will not hesitate to eat mites, insect eggs, or even each other. Beauty meet brutality. And when danger strikes, these adorable beetles reveal another side entirely. They perform something called reflex bleeding, releasing droplets of yellow-orange fluid from their legs. This liquid isn't blood as we know it, but a cocktail of toxic alkaloids that smell terrible and taste even worse. To birds, frogs, and other predators, that smell is a clear warning. Eat me at your own risk. Yet, this same noxious defense may hold promise for humans. Scientists are exploring whether ladybug chemicals can be used in natural pesticides or medicines. Some of their compounds have antibacterial properties that could inspire future drugs or eco-friendly pest repellents. Dr. Emily Torres, an entomologist at Greenfield University, has dedicated her life to studying these remarkable beetles. Her lab looks like a jewelry box brought to life. Hundreds of pinned specimens in brilliant reds, oranges, yellows, even deep blues. Most people think ladybugs are just red with black spots. Emily laughs. But nature has painted them in over 6,000 unique designs. And each one has a story. Some species, like the two-spotted ladybug, Adalia bipunctata, are native to Europe and North America. Others, like the Asian ladybug, Harmonia axyridis, were introduced to new regions for pest control and became invasive, outcompeting local species. In the UK, scientists estimate that native ladybugs have declined by nearly 30% in areas where the Asian ladybug spread. It's a reminder that even well-intentioned solutions can shift the balance of ecosystems. But Emily's research focuses on something subtler and perhaps even more extraordinary: the perfume of fear. When we think about predators, we imagine hunting, chasing, eating, she says. But ladybugs can control aphids just by existing near them. Aphids, it turns out, have evolved to smell danger. They detect the odor of ladybugs and instantly change their behavior. They stop feeding, stop reproducing, or even drop off plants entirely. Emily's lab collects these odors, a complex chemical blend of dozens of compounds, and tests them like perfumers. Some people say ladybugs smell like roasted peppers or potatoes. Others describe it as musty, metallic, or greasy. Whatever you think it smells like, she says, aphids think it smells like doom. Her team is working on using these fear perfumes in sustainable agriculture. Instead of spraying synthetic insecticides, farmers could apply a natural ladybug scent to crops. The smell would repel aphids, lower their reproduction rate, and protect plants, all without killing beneficial insects or harming the environment. This approach could help reduce global pesticide use, which currently exceeds 4 million tons per year. Excess pesticides contaminate soil, water, and pollinator populations, including bees. Ladybugs, by contrast, offer a built-in eco-solution: efficient, renewable, and self-sustaining. Still, Emily warns, not everything is simple. Ladybugs themselves face growing challenges from habitat loss, climate change, and parasites like the Dinocampus coccinelli wasp, which injects its egg into a living ladybug. The larva eats the beetle from the inside out, then forces its zombified host to guard its cocoon. Nature, as Emily often reminds her students, is beautiful, but rarely gentle. Ladybugs' roles extend far beyond farms. They're found on nearly every continent except Antarctica, thriving in forests, grasslands, deserts, and even cities. In the Swiss Alps, some species hibernate under snow, slowing their metabolism to survive freezing temperatures. In tropical Asia, others remain active year-round, feeding on scale insects and mealybugs. And yes, they even have love lives worth mentioning. Ladybugs are prolific breeders. Females can lay up to 1,000 eggs in a season, usually on leaves near aphid colonies. Their larvae, black and spiky like tiny dragons, emerge within days and immediately begin feasting. It's a short but intense life cycle. A single generation can mature in just a few weeks under ideal conditions. Across the globe, people have found creative ways to celebrate these insects. In Italy, ladybugs are symbols of love. In Russia, they're God's little cows. In some Native American legends, ladybugs represent renewal and protection. Even NASA once studied their flight mechanics to design more efficient miniature drones. Dr. Torres didn't always dream of studying bugs. I wanted to be a singer, she admits with a grin. But one summer, I took a research job and fell in love with insect behavior. They're like alien civilizations right under our noses. Now her work could transform modern farming and deepen our understanding of how species communicate through chemistry. Every molecule tells a story, she says. The ladybug story is one of coexistence, how beauty and danger, fear and survival are all intertwined. From the tulip fields of Holland to the wheat plains of Kansas, from children chasing specks of color in their gardens to researchers decoding invisible scents in high-tech labs, the legacy of the ladybug continues to grow. They're not just cute dots on a leaf. They're engineers of ecosystems, protectors of crops, and reminders that even the tiniest creatures can have the biggest impact. So next time one lands on your hand, don't just make a wish, take a closer look. You're holding a living miracle, a tiny titan of nature, wearing armor painted by evolution itself.